Hi, I'm Deepak from Reliant Institute of Oil and Gas. Greetings to you all. So, in last video, Welding Inspection Series 1 Part 2, we have completed SMAW, and in this Welding Inspection Series 1 Part 3, we are going to cover TIG welding process. So, what is TIG welding or GTAW? So, GTAW, gas tungsten arc welding. Okay, so GTAW, gas tungsten arc welding. So here we are using a gas. So in our previous video I have explained like why or what is the purpose for using shielding gases. So again I'll mention that. So this shielding gas is mainly to avoid contamination, okay, atmospheric contamination, and also to protect the weld from the contamination, atmospheric contamination, and also to protect the tungsten electrode in this process. So we are using gas, shielding gas, especially inert gas. So that's why the name came as TIG welding process, tungsten inert gas welding. So the gas which we are using is inert type. So there are two types of inert gases. So we have argon or we have helium. Okay, argon or helium. So helium is now restricted because of highly inflammable gas. So considering the safety issues and safety precautions, we are stopped with helium gas, and very commonly we are using argon for the welding, TIG welding process. So what is the purpose of TIG welding process? Why we have to choose, or when we have to choose TIG welding? So in the case of SMAW process, we have discussed that the SMAW process above 5 mm for any thickness, or wherever the MIG torch or TIG torch is not entering that welding area or the design, constricted design, so we go for the stick welding, otherwise SMAW process or MMA. So all three are same. SMAW process, shielded metal arc welding, is a American term. British term is manual metal arc welding, and colloquially we call it as a stick welding or just general arc welding. But this stick welding is precisely for high quality. When you are high quality welds, producing high quality welds, clean welds, and even you want to avoid impurity, like for example something like excessive defects like porosities, or to avoid cracking. Even in this TIG welding process, the hydrogen level is very low, so we no need to worry about hydrogen crack or HAZ crack or parent metal cracking, because basically in TIG welding process the hydrogen level is below 3 ml per 100 grams of weld metal. So if you take 100 grams of weld metal, you can able to find only less than 3 ml of hydrogen, so which is not a threat for the joint, or it will not create any cracking or hydrogen cracking, because for hydrogen cracking more than 15 ml per 100 grams of weld metal, in that level there is a chance for getting an hydrogen crack. So the TIG is having a least hydrogen level, and it is mainly preferred for high quality, clean, precise welding. Okay, so and more preferred for stainless steel and even in aluminum fabrication and even in alloy steels. So when it comes with the aluminum welding, so TIG performs very well. At the same time, especially ASME B31.3 process pipeline welding, so we go for TIG welding of stainless steel pipe. So we can avoid more problem, especially like cracking or any porosities, something else like that. So when it comes to the thickness range, starting from 3 mm but up to 12 mm possibly we can make weld. So the material thickness maximum 12 mm, up to 12 mm only we can go for TIG welding. But if it is above 12 mm or even if you require more heat input, or if you need more arc energy, even the density is very high, the density of the material is very high, then you have to go for either MIG-MAG, SMAW, or it is better to go with SAW process, submerged arc welding process. So that is one drawback in this TIG welding process. When it comes to the material type, any type of steels, especially stainless steel, it works well. Alloy steels and aluminum fabrication or aluminum welding. In this process, the electrode we are using is non-consumable electrode. So in the TIG welding process, the tungsten electrode is non-consumable tungsten electrode. So what is non-consumable tungsten electrode? So during the welding, the tungsten electrode will not melt or become a part of welding, like forming a weld. So in TIG welding, the tungsten electrode is not melting, it is only used to form a arc, and in the arc we use filler rod or filler wire which is of same material as of the parent material. For example, if it is a stainless steel, we use stainless steel filler rod. If it is carbon steel, we use carbon steel filler rod. If it is an aluminum, we use aluminum filler rod. But the electrode will not melt. Why? So the melting point of tungsten and we have steel. Okay, so both are different. And even when we talk about aluminum, okay, so the tungsten 3370 degree Celsius. This is the melting point of tungsten. Whereas the steel is around 1400 degrees Celsius or below 2000 degrees Celsius, it will melt. And whereas the aluminum is around 600 degrees Celsius or below 1000 degrees Celsius. So the aluminum will melt. But the tungsten melting point is 3400 or 3000, exactly 3370 degree, approx 3400 degree. So which makes the tungsten not to melt during the welding. Okay, so we use a filler or filler rod or wire with different diameters, but the material is same as of parent metal. Okay, so the parent material is, for example, okay, so if this is carbon steel, so this is the torch, this is the tungsten electrode. So the tungsten electrode will produce arc, and in the arc, and this is called filler, where the filler is also carbon steel. The electrode is tungsten, produces an arc, and in the arc we introduce the filler, and that filler should be same material as of the parent metal. So this is the parent metal. So if the parent metal is carbon steel, then filler has to be a carbon steel. So the carbon steel filler rod melts in the arc, and it is filled here to make a welded joint. Okay, so what about the process type? It is a manual process. So what are the manual process? Both SMAW and TIG is a manual welding process. Okay, so TIG is also a manual welding process. Then same like SMAW process, the power source is constant current. That means if we set some current value initially, it doesn't mean that since it is a constant current, it doesn't mean it will not change. There will be a minute or small variation when compared to the voltage. So in manual welding, based on arc length, the arc voltage will vary. Okay, so what is arc length? So this is the arc and this is the electrode and this is arc length. So arc length is proportional to arc voltage. If arc length increases, arc voltage increases. If arc length decreases, arc voltage decreases, drops down. So in the manual welding, this distance will vary, will change when we do the manual welding. So in TIG as well as in SMAW process, the arc length will vary. That means there will be a drastic variation in the voltage, but the current will be almost constant. For example, if you are setting 80 amps, it will be like 82 or 79, 78, again 80, again 81. Like this small variation will happen, but voltage will not be like that. Drastic variation will happen. So what about the polarity current type? Here we can use AC or DC. When it comes with the DC, we have two polarities. In SMAW process, very commonly used polarity in direct current is DC EP or electrode positive or DC positive. So whereas in the TIG welding process, DC positive is not used. Okay, DC positive is not used. Why DC positive is not used? Because it causes overheating. It produces overheating of electrode, and due to the thermal shock in the electrode, sometimes the electrode contacts the weld pool. Due to these high when it comes to the heat, so DC EP makes the electrode overheated, and sometimes the tip will break and falls off into the weld pool, and later on we can identify that in the radiographic testing, and while doing our interpretation RTFI, we can able to find tungsten inclusion. So that is the major problem. If we use DC EP, we get tungsten inclusion. So and also, most of the cases the material too much heat produces, then variation in heat input, fast cooling effect, cracking can also happen. So considering many criteria, so DC EP is not at all used in TIG welding process. So very commonly we use DC EN for steels. Okay, DC EN is used for steels. Then aluminum is for AC is for aluminum. Okay, so for aluminum we use AC, for steel we use DC. In that we use DC EN or DC negative. Okay. Then what about the position? Any position we can use. Groove position, any fillet position. When it comes to the plate welding, structural welding, or even in the pipelines, any position we can use TIG welding process, and even it will be very easy to do overhead welding or even 6G welding with the case of TIG welding process, because you have more control when compared to the other welding process. So SMAW, GMAW, SAW, TIG is smooth and even moderate heat input, and also we have a good control. That's why most of the cases TIG welding is also used in metal art. Okay. So shielding gas, as I told already, argon is very commonly used, and it is always a practice of welding stainless steel process pipeline. So maximum for stainless steel process pipeline welding we use TIG welding, and the shielding gas will be the argon, and also we follow some special technique called back purging. Okay, so back purging is something like we fill the argon gas into the pipe, and the argon gas removes all the oxygen or unwanted gases out of the pipe, and then we perform root welding, hot pass, and then we stop filling the argon into the pipe, and this helps to protect or prevent the root from oxidation process. So in some cases, if you are preparing for CSIP, so they call it as a root choking, or we call it as a root oxidation. Okay, so to avoid the root oxidation and considering the cleanliness of the root and also the penetration level of the root, and also to avoid the oxidation, contamination of the root, we do back purging, especially in the case of stainless steel pipeline welding. So this is how the TIG welding looks. So very thin sections, stainless steel, we go for TIG welding process. So this is the TIG torch. Okay, so this is the torch, this is the filler, this is the filler, and this is the torch, and this is, we call it as a ceramic cup, the pink one. This is called as a ceramic cup or nozzle. Here in the arc, the filler rod will melt and forms the weld, or makes a joint. So here you can see a drawing of TIG welding. So here we have a welding rod. Here they have colloquially said that, but actually it is a filler. So it is a filler rod or filler wire, and this is the tungsten electrode, non-consumable tungsten electrode, and this is the shielding gas, and this is the arc. This is the arc, and in the arc it will melt and it will be forming a weld metal, and we are using inert gas, especially argon, and then the power source is DC, EN or AC, and also constant current power source. Okay, so you can see here again, this is the torch, so modern torch. So this is the ceramic cup or ceramic nozzle, and this is the filler rod or filler wire, and in the arc the filler wire is melting and forms a weld. So these are the different TIG torches, different types of TIG torches, different sizes, different applications. We have two types of torches here. So in the TIG torch, basically we can differentiate into two types. So one is water cooled torch, another one is gas cooled or air cooled torch. So water cooled, gas cooling. So in water cooled torch, separate water circulation will be there to avoid overheating of electrode. Sometimes we supply air, or even the gas, shielding gas itself can control the heating level of the electrode, tungsten electrode. So in the tungsten electrode, when you see, so in the tip, in the welding area, we make a special design. So we have vertex tip, we have flat tip, and we also have ball tip or ball end. But all three are having a different requirement and application. So in the other end of the electrode, you can see some color. They would have painted it or colored it. So based on the color, we can identify what type of tungsten electrode it is there. So in previous classes, you would have we came across the classification of electrode. So there is a code like E6013, E7018, something else like that, AWS code. But here we are having a color coding. Based on color code, we can identify whether it is a pure tungsten electrode, zirconiated tungsten electrode, lanthaniated, seriated, thoriated, etc. So this is an end cap or tungsten housing or electrode holder, we say. So once we insert, this is the collet, or we can also call it as a contact tube. Contact tube. So this one is holding the contact tube, and all these three will be inside this ceramic nozzle. Okay, so first inside there will be a collet or contact tube, and that contact tube will be inside or inserted in the collet holder, and in the collet or contact tube the electrode is inserted. Now all these three setup will be inserted into the ceramic cup, and this ceramic cup will be connected here, and in between there will be a gas diffuser which will diffuse the shielding gas, and the half of this electrode will be held by the electrode holder to adjust the stick out length, and then we tighten this electrode housing so to to avoid the electrode moving further or to maintain the stick out length. And here we have on off switch. Sometimes we have a wheel like something to adjust the the intensity of arc, something like that. So end cap, collet or contact tube, collet body, gas diffuser, heat shield. So this to avoid the overheating of electrode. And here we have tungsten electrode, ceramic cup. So just before I said that the electrode tip is prepared for different application. If we sharpen the tip like this, so this one is called vertex tip or vertex end. So this is most probably used in DC mode, especially in DC EN, and also mainly for steels. So when this tip is cut off, it will be like this. So we call it as a flat end. We call it as a flat end. So this is mainly for like we can use both in DC or AC, that means steel or aluminum. So when it comes with the balled end, so it is short circuited, little bit melted, and then the tip will become a ball type. Now this ball end is mainly for lower current welding. For example, AC, we can use only with the AC only. So the ball tip can be used only with AC, whereas the vertex only DC. So only with DC we use vertex, only with AC we use ball end. Either DC or AC we go for flat tip or flat end. So when you see here, this is what I said, the tungsten electrodes are classified based on the color coding. So there are different types of tungsten electrodes. So we have pure tungsten, we have zirconiated, that means the tungsten mixed with zirconium, and we have thoriated, which is widely used for steels. Okay, so thoriated, so where it contains 2% of thoria. Then we have ceriated tungsten, lanthanum is mixed, so lanthaniated tungsten. So if you see here, the pure tungsten, okay, is mainly for aluminum and can be used only with the AC mode. And zirconiated is also for aluminum and can be only used with AC. But thoriated only for steels in DC EN. And ceriated we can go sometimes DC or AC, aluminum or steel. Lanthaniated mostly used for steels with DC EN. Okay. So pure tungsten, always if you see green color, okay, if you see green color in the end, so you can come to a confirmation that it is pure tungsten electrode. So the zirconiated are having a white color codes, and the thoriated, which is very common general type, so general type for steels. Okay. So gray or orange, most probably gray, for ceriated type, ceriated electrodes, tungsten electrodes. Black, gold, blue. So here you can see gold, here blue. These are very common for the lanthaniated. So you can see here list of the what are the maximum current type and polarity, color code, then the types of tungsten electrode. So now we are about to talk about the purging, gas purging. In the stainless steel material, pipeline or any kind of pipeline welding or pipe work, if it is stainless steel, to avoid the root oxidation, we use back purging. So in back purging, usually if this is a pipe, okay, so here we close the ends. Sometimes we use something like this. So we cover this area and we try to fill argon gas. So when the argon gas is filled here, it removes or expels all the oxygen or any other unwanted gas. So when the steel root weld, okay, exposes to the oxygen or air, so what happens? The ferric oxide is formed. Okay, the hot root weld reacts with oxygen. The iron content or the ferrous in the steel root weld reacts with the oxygen and forms ferric oxide. And this process is called oxidation. So to avoid root oxidation, so this back purging not for plate welding. So back purging is not for plate welding, only for the SS pipe welding. Okay. So you can see here, if you do the purging, you have a quality like this. If you don't do the purging, without purging, if you do the welding, the quality will be like this. So mostly in stainless steel manufacturing, fabrication, pipeline construction, we do back purging when it comes to the TIG welding process. So stick out length. What is stick out length? This is nozzle, ceramic nozzle or ceramic cup, we'll say, and this is the, actually this is what? Tungsten electrode. Tungsten electrode, and this distance is called stick out length. So this is a special equipments. So there are different equipments the welders use to adjust the stick out length, to set the stick out length. So if you see here, this is also available in welding market or industrial sites, so you can purchase this. So different stick out length you can adjust by inserting, you have to hold, place the ceramic nozzle here, move the electrode, it will enter. So this will be like 4 mm, 5 mm, 6 mm, 7 mm, 8 mm, 9 mm, 10 mm, like that. So these are the different stick out lengths you can go with. Okay. So here there is a standard dimensions for the stick out length using this gauge, stick out length gauge. Then argon cylinders, so we use both for, here I mentioned shielding gas, but even for back purging we use argon. Sometimes we go with duplex stainless steel. Okay, for duplex stainless steel, sometimes for shielding purpose, we go with argon plus hydrogen, and for back purging we go with argon plus nitrogen, especially for duplex stainless steel. So duplex stainless steel is very common in offshores or any of the precise pipeline projects, process pipeline projects, because duplex stainless steel is having a very high level of corrosion resistance. Okay. So this is a regulator or a gauge. So this is the regulator. Okay, and this is a pressure gauge. Okay, flow meter and pressure gauge. If you see here in this regulator, the pressure gauge is here and also the flow meter is here. So the shielding gas flow rate sometimes measured in cubic feet per hour or liters per minute. Okay, cubic feet per hour, or CFH, or this L, liters per minute. And even in pressure gauge, sometimes we go with PSI, pounds per square inch, or sometimes we go with the Pascal, megapascal, etc. Okay. So finally we come to a conclusion that TIG welding is a manual welding, first thing, then very clean welds, precise welds, and even good control, but skill is very high skill required for the TIG welding. Unless you can't able to perform SMAW process properly, then TIG welding is quite difficult for you. So, but if you are good in SMAW or general arc welding, then you can practice TIG welding. And even TIG welders, MIG welders are very highly paid when compared to the stick welders. And TIG welding most probably used in refinery, process lines, even non-ferrous fabrication. So, in this we use additionally shielding gas for protection of weld as well as the electrode. And another point is, the TIG welding is a manual welding, and the electrode is a non-consumable electrode. Only the filler rod is consumed during the welding and makes the joint. So with this we conclude. I hope that you have understood all the points discussed. So if you have any doubts, please contact us to the given contact details in the description. Then we will see in the next part 4, SAW, submerged arc welding. Thank you.